What if I told you that an object, billions of years old, traveling faster than anything in our solar system, has just flown in from deep interstellar space? And it's not just any rock. This isn't science fiction, it's 100% real. It's called 3I/ATLAS, the third confirmed interstellar visitor ever detected. And it's unlike anything we've seen before. It's hurtling through space at over 100,000 kilometers per hour. It's active, spewing gas and dust like a comet, but it's not from here. And some scientists are whispering what others won't say out loud. Could it be artificial? Could it be a probe, a vessel, a message? We'll break down everything, the facts, the weird science, and the wildest theories. If you're into space mysteries, conspiracies, and science that bends the rules, smash that like button and subscribe. There's so much more where this came from. Let's unravel the secrets of 3I/ATLAS. 3I/ATLAS was officially discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System ATLAS telescope in Chile. At first glance, it looked like just another long-period comet, icy, distant, and faint. But as astronomers tracked its orbit, something strange became clear. Its trajectory made no sense. Unlike typical comets bound to the sun, 3I/ATLAS was on a hyperbolic orbit, meaning it wasn't coming back. It wasn't from the outer solar system or the Oort Cloud. It was an outsider blazing in from interstellar space. The object was quickly classified as 3I/Atlas, short for Third Interstellar Object, following in the footsteps of 1I/Oumuamua, 2017, and 2I/Borisov, 2019. The C/2025 NN1 tag also marks it as a non-periodic comet. What really raised eyebrows, unlike the oddly shaped, rock-like Oumuamua as a this one looked and behaved like a normal comet, but it wasn't from our solar system. That changed everything. Astronomers around the globe scrambled to get a closer look. From the moment astronomers plotted its course, 3I/ATLAS stood out like a cosmic outlaw. Its orbit wasn't just long and looping, it was hyperbolic, with an eccentricity so extreme it left no doubt. This object came from outside our solar system. Most comets travel in elliptical orbits, meaning they swing around the sun and eventually come back. But 3I/ATLAS is on a one-way trip. It's moving too fast, over 100,000 kilometers per hour, to be caught by the sun's gravity. Instead, it's slicing through our solar system at a steep angle and will never return. But where did it come from? The data suggests an origin far beyond the Oort Cloud, likely from the thick disk of the Milky Way, a population of stars and debris billions of years older than our sun. That means 3I/ATLAS could be older than the solar system itself. Let that sink in. We're watching a piece of another star system fly by right now. Its path took it past Mars in early October 2025, and it will swing near Earth about 1.8 astronomical units away in December. But don't expect a dramatic sky show. It's faint, fast, and fleeting. Still, its wild speed and bizarre angle are like fingerprints, and those fingerprints say alien origin in the literal astronomical sense. Unlike the strange, tumbling Oumuamua, 3I/ATLAS behaves like a textbook comet, but it's anything but ordinary. From the moment it was spotted, telescopes detected a coma, the cloud of gas and dust that forms when a comet heats up near the sun. That means 3I/ATLAS is active, venting material as it travels, proof that it's not just a dead rock. Estimates suggest the nucleus of 3I/Atlas is somewhere between 0.3 and 5.6 kilometers wide, though it's hard to pin down because of the glowing coma. That coma, by the way, stretches tens of thousands of kilometers, a shimmering halo of ancient material, untouched for billions of years until now. But it's what's inside that really shocks scientists. Spectroscopic data from instruments like JWST and VLT revealed a composition rich in carbon dioxide, CO2, with traces of carbon monoxide, CO, water ice, cyanide, CN, nickel vapor, and even carbonyl sulfide, a chemical that rarely shows up in solar system comets. These compounds hint at an origin in a much colder, more chemically unique environment, possibly in a distant protoplanetary disk that never formed into planets. Some researchers believe its chemical fingerprint doesn't match anything we've seen locally. That makes 3I Atlas a rare time capsule, a chunk of raw, untouched material from another star system, older than Earth itself. Every molecule, every outgassing puff could reveal secrets about how planets form in other parts of the galaxy. And yet, a few scientists are asking, if it's that different, is it really natural? The moment astronomers realized 3I Atlas was interstellar, the race to observe it was on. Time on the world's most powerful telescopes was quickly booked. From space and from Earth, scientists pointed every lens they had at this cosmic intruder. The Hubble Space Telescope was among the first to capture high-resolution images of its coma and tail, revealing how it was shedding material as it neared the Sun. But it was the James Webb Space Telescope, JWST, that truly changed the game. Using its NR-spec instrument, JWST analyzed the comet's infrared light, exposing a detailed chemical signature, one unlike any local comet. Ground-based observatories like Gemini South, Very Large Telescope, and SWIFT added even more layers. SWIFT, in particular, detected signs of water vapor and CO2 emissions, evidence that the comet was undergoing active sublimation as it approached the inner solar system. Then there's SphereX, NASA's infrared survey mission, which caught glimpses of 3I Atlas as part of its wide sky monitoring. Its data helped build a timeline of how the comet evolved over weeks, watching its coma grow, shift, and react to solar radiation. What made this interstellar visitor even more fascinating was how instruments detected certain elements not usually seen in solar system comets, like the faint signature of nickel gas. That's incredibly rare, suggesting high-temperature processing in its distant past. Altogether, these observations are building a profile that's never been seen before. A comet that behaves familiar, but carries the DNA of another star system. The journey of 3I Atlas through our solar system is a brief but spectacular one. After entering from deep space, it began to brighten as it neared the Sun. The comet reached its perihelion, the closest point to the Sun, on October 29, 2025, at about 136 astronomical units, AU, which is just beyond Earth's orbit. But Earth won't get a close look. Its closest approach to our planet happened in mid-December 2025 at around 1.8 AU, about 270 million kilometers away. That's nearly twice the distance from Earth to the Sun, so while it won't light up our skies like a traditional comet, astronomers had a small window to gather as much data as possible. Interestingly, 3I Atlas passed much closer to Mars in early October, about 0.19 AU, and later made a relatively near pass by Venus in November at roughly 0.65 AU. The timing of its approach was perfect. Major telescopes were online and the comet was active, but it's moving fast. By early 2026, 3I Atlas will already be on its way back into interstellar space, never to return. And with it goes a piece of another world, leaving more questions than answers. To astronomers, 3I Atlas is a once-in-a-lifetime opportunity, a rare chance to study something that formed around a completely different star. Unlike Oumuamua, which was mysterious but inactive, 3I Atlas is a fully active comet, venting ancient gas and dust into space as it heats up. That activity gives scientists direct access to its interstellar chemistry. Why does this matter? Because studying 3I Atlas is like opening a time capsule. Its materials likely formed in the earliest stages of another solar system, possibly billions of years ago, then were ejected into space by gravitational interactions or stellar events. That means this tiny object could carry clues about how planets and comets form elsewhere in the galaxy. Even more intriguing is the idea that interstellar objects like 3I Atlas might be common, just hard to detect. With telescopes like JWST and upcoming missions like the Vera Rubin Observatory, scientists hope to catch many more of these travelers in the future. The unique chemical fingerprint of 3I Atlas, including rare molecules like carbonyl sulfide and nickel gas, challenges our assumptions about what comets should contain. It forces scientists to rethink models of planetary formation, not just in our solar system, but everywhere. Finally, interstellar objects raise deeper questions. Could they carry organic material? Or even the building blocks of life? Could they be responsible for seeding life across star systems? He said Atlas doesn't give all the answers, but it sparks the right questions. And that's where real discovery begins. Where there's mystery, there's speculation, and 3I Atlas is no exception. While the majority of scientists agree it's a natural interstellar comet, some voices outside the mainstream have suggested otherwise. One of the most prominent is Harvard astrophysicist Avi Loeb, known for his controversial theories about Oumuamua being an artificial object. Although he hasn't made strong claims about 3I Atlas yet, others have picked up the thread. Some fringe theorists argue that the chemical anomalies, like nickel vapor or unusual outgassing patterns, could suggest non-natural origins. A probe? A discarded alien engine? A long-dead craft? Most experts dismiss these ideas. They point to the comet's clear gas emissions, natural trajectory, and typical coma behavior as strong evidence of a natural origin. The composition, while unique, still fits within what's possible in other star systems. However, the fact that these questions are even being asked shows just how fascinating interstellar objects have become. When something travels billions of kilometers from an unknown origin, it's only natural to wonder what else is out there, whether natural or not. 3I Atlas keeps the door open for bold ideas, and in science, that's often how breakthroughs begin. 3I Atlas is more than just a comet. It's a message in a bottle from another star system, drifting through our solar neighborhood for just a moment. It reminds us how small we are, how much we don't know, and how many secrets the universe still holds. Whether it's a frozen relic or something stranger, one thing's certain, it's made us ask big questions. Thanks for watching. If you made it this far, you're clearly as curious as we are, so don't forget to like this video and subscribe. Most of you watching still aren't subscribed. Let's explore the unknown together.